Hey everybody, welcome back. So in my last video, I walked through refactoring an API route to use the controller service repository architecture. And in that video, I introduced the term dependency injection, and I suggested that the dependency injection pattern helps make your code more testable. So in this video, I just wanted to show how dependency injection can make code easily testable, and I also wanted to introduce a tool called GoMock. If you didn't watch that last video, no worries at all. I do recommend you go watch it, but I'm going to walk through right now what we accomplished. So here I am in the main.go file, pretty much the only file in this repository, which by the way, I'll link in the description. But essentially what we have here, if we go down to the main function, is we initialize a couple different structs, and we initialize a HTTP server with one route, get/books, and we use the handle getAllBooks method on the book controller as the handler for that route. So before I dive any deeper into the code, let me just show you what this actually does. If I run main.go here, listening on port 8080, and then I'll create a new terminal session, and I will curl, there it is, the localhost/books endpoint, I get all of the books in our SQLite database. So going back to the code here, we have a book repository, a book service, and a book controller. These are all structs with methods on them. The book controller is responsible for the HTTP logic, so getting the request and producing a response. The book service is responsible for the business logic, which right now is just calling into book repository, and book repository is responsible for handling the database operations. In this case, it's calling into our ORM. So our handler is broken down into these layers here: controller, service, and repository. And each of these layers has their own responsibility and their own dependencies. So the nice thing about structuring your application like this is that it lends nicely to structuring your code base and the packages within your code base. So instead of defining all of these structs and interfaces in the main.go file, we can make respective repository, service, and controller packages, and then put the respective interfaces and structs in those packages to really clearly delineate the dependencies and will isolate the responsibilities. So that's the first step I'm going to do here, is I'm going to separate these into packages. So the lowest layer we have in our system is the repository layer. So I'll go ahead and create a new directory repository that will contain our repository package. And then inside this, we'll create a book.go file that will contain the specific book repository details. Okay, so here's book.go, and I'll go ahead and enter into it, and then I will create a split where this one is main.go, so we can clearly see it. Now let's just go ahead and copy over all the book repository into this file, and then this is package repository. And then we'll need to pull in some imports here, and then looks like that may be it. Okay, so now we'll do the same for service. Go ahead and create a service directory, and again book.go, and paste in all of that service stuff. And then this is package service, and we'll import again the context, and again query package that has our data models in it. And then instead of book repository, we have repository.book repository. Finally, we have the controller, so let's one more time do controller/book.go. Go ahead and paste in our book controller stuff, package controller, and then we'll add HTTP, we'll add book service, that's in service.bookservice. And then also we have these write error and write JSON functions. These can go in like a util file. I'm not sure if utils is everyone's favorite naming convention for something like this, but it makes sense to have HTTP specific utils in our controller package, since the controller cares about HTTP specifics. So I'm going to go ahead and put it here for now. And then package controller. Can get rid of these unnecessary imports now from main. Now when we go to instantiate everything, we have a repository.book repository impl. I'll go ahead and make this full screen. We have a service.book service, and then a controller.book controller. And so one of the issues we're running into now is that our fields are private on these structs. So actually what I'm going to do is go ahead and create constructors for these structs. So going first to the repository package, let's create a func new book repository, and it will take in queries and return a book repository. And then here we'll return a book repository impl with queries set to queries. So now in main, instead of initializing the struct like this, we'll do repository.new book repository and pass in queries. Okay, so that's a pretty basic pattern. Let's go ahead and do the same for the service and controller. And I just noticed that we imported the wrong service here, so we want to go back down to service and import our own service. Now we'll go here, return a book service, and then do the same thing where we have the book service impl, and it will take a book repository. Okay, then go back here and do service.new book service and pass in the book repository. And lastly, we want to do this for the book controller here with the book service being the one we pass in. And do controller.new book controller, pass in the book service. And there we go. So now we've refactored everything a little bit. It's a little bit nicer here where we have specific constructors for each repository, service, and controller. Again, let's make sure everything works. So I'll go ahead and spin this up again, wait for it to start listening, and then fire off another curl, and we get everything. So it looks like everything's working the same. One thing I'll call out right now is that if we go into like the repository package, for example, we can see the dependencies so clearly. Like repository only depends on query here. It's not communicating with the service at all. It's not communicating with the controller at all. But then we go to controller and we see that controller only depends on the service package, right? So it's not directly communicating with the repository at all. So this layered architecture that I've talked about is made very explicit when you split up your code into these packages. Great, so now I want to write tests for the functions like this on our controller, our service, and our repository. So starting with the book controller, we can go into controller/now booktest.go, and we can start writing some tests for the book controller. Now inside book test here, we'll create the package, and I'm going to choose controller test, and controller test is separate from the controller package. And that makes sure that we're actually only testing the things that are exported out of the controller package. When you write your tests in the same package as the code that you're exporting, you might be tempted to use some of the code that's actually internal to that package. But really, we just want to test the interface of the package, the actual things that are exported, because consumers won't be able to use any internal functions when they're consuming your package. So the thing we actually want to test here is handle get all books. So I'll create a test handle get all books. And then all of our Go tests take a testing.t. And then something we might actually want to test is that it responds with JSON containing the books. So the way to do this is we do t.run, and then we give the function a name with JSON containing all the books. And then it needs a callback here. And now we can start running our specific test here. So the pattern I like to follow when I'm writing tests is arrange, act, and assert. So in arrange, we want to construct the things that we'll be testing on. So we want to construct a book controller. Here I have book controller. Let's do controller.new book controller. And now we need to pass in a book service. Now remember, the book service is an interface, right? This was key to the dependency injection, is that we're passing in an interface as opposed to an actual implementation. So while we could go ahead and pass in our actual service, we might not actually want to communicate with our database during our tests. Still though, we could pass in a real service and a real repository. So let's go ahead and try it. I'll create a book service just like we do in main, where it's service.new book service. And then I'll create a new book repository, which is repository.new book repository, and that will take queries. So here we'll pass in book service, here we'll pass in book repository, and then here we need to pass in the queries object, and we could actually use our real database. So here I'll go ahead and copy the code from main to open a connection to the SQLite database. Okay, so now we're opening a connection to an actual database, and we're constructing all of our repository, our service, and our controller, and then we can go ahead and act on the controller. So to act, what we are actually testing is book controller.handle get all books, and that's going to take a response writer and an HTTP request. So the request can just be an HTTP request object. So that's going to be http.new request. This is a get request to /books, and we're not passing in a request body, so that can be nil. And the response, since we're in a testing environment, we can use http test.new recorder. This will record the output of our HTTP handler. Excellent, so now we can pass in a request and response here. So we pass in the response writer and the request. And now we want to assert on the response. Now, because we're hitting our actual database and we're not doing any sort of data setup, this should return actual data, which was, as we saw before, these two books. And so we should just expect this JSON string here. So I've gone ahead and pasted this JSON here, and now I'll format it a little bit. So here's the big long JSON string, and I've put it in a variable called expected. And then we want to make sure that the expected is equal to what we actually get. So actual is equal to response.body.string. And if expected does not equal actual, we are going to throw an error. And that error can say expected %s received %s, where the first string is expected and the second string is actual. Okay, now let's go ahead and run our test. So this is go test, and then I'm using verbose with the /controller directory, which is our controller package. And when I run the test, it fails because we need to open the SQLite drivers. So we need one more import here. Then I'll go ahead and rerun it. And we're failing because our database path is wrong because we're in a completely different file. So now when we run go test, we get a pass. Awesome. So our test passes and our controller is spitting out the right response given the request. So as I was alluding to before, we are using all of the layers of our application in this unit test for the controller package. And so in my mind, and maybe in yours as well, this doesn't seem like a very good unit test because we're not doing a good job of isolating the controller unit. Now, do I think that these end-to-end tests are useful? Absolutely. In fact, you can set up a test SQLite database with test data and produce really simple end-to-end tests that fill the database with mock data and access the actual database. But when we want to isolate our code units and test specific behavior, we don't want to have to use all of the layers. In this case, our service and repository layers are fairly simple, but when you start adding more databases and more dependencies, it'll really be hard to test the controller unit in this way. So what we really want is a way to stub or mock out the behavior of these other layers while we're testing the controller layer. And an awesome code generation tool that helps us do that is called GoMock. So here I'm on the ubergo/mock repository. I'll link this in the description below. But we can quickly install this with go install, and then we can start generating awesome mocks that help us really test our units. So again, run that go install command, and you should be able to do mockgen/version to get the current version of the package. Now, I always recommend reading the docs. It's very useful, but I'm going to show you how I've been using GoMock in my projects. The first thing I'm going to do is create a new package called mocks, specifically for storing the mocks of all of our other packages. Let's go ahead and do makedir mocks. And now we can run the mockgen command to generate mocks for our service, for example. So I'm going to run mockgen-destination. And because I'm going to generate service mocks, I want them to end up in the service.go file within the mocks package. So let's do /mocks/service.go. And then the name of that package is going to be mocks, and then the package from which I want to create the mocks is the service package, which in this repo is this big long GitHub string, which is copied from our imports in our code here. Okay, and the last thing I need to do is give a comma-separated lists of the interfaces that I want to mock. So here I just want to mock book service, and let's go ahead and run the command. And when I run it, I don't have the right packages, so I need to run go get here, and then let's do the mockgen again, and it didn't give me any errors. So if I clear and I ls, let's do ls mocks, and I have a service.go in there. So if I go to mocks/service.go, we see it spit out a bunch of code, and this is the mock book service that we were looking for. So some of the key things here is that it created a mock book service that is, as it says, a mock of the book service interface. So this means that when we go to construct our controller, we can actually just pass in this struct and it'll work because it implements the interface. So when we go to construct the mock book service, we'll use this function here, and then this expect function is how we're going to assert that certain operations ran on our mock book service. I'll show you what that looks like. So let's go back to our book test, and instead of connecting all the way to the database, let's now use the mock book service. So delete these, and then book service will now be mocks.new mock book service, and we're going to need to pass in the GoMock controller. So this controller is just a wrapper around T. So let's do GoMock.new controller, and then we'll pass in the T object. This is again our controller, which we will pass into here. Now, don't get confused. The GoMock controller, what they're calling the controller object, is totally separate from what we have as our controller interface. The controller in our layer is responsible for HTTP stuff, and that controller is responsible for GoMock stuff. They just happen to have the same name. So now I get to delete a lot of imports from this test. And yeah, there's a naming conflict here. So let's go ahead and rename this to something like CTRL, short for controller. And then let's actually re-import the actual controller since I accidentally removed that import, and our test should be good again. However, now, since we're not hitting the actual database, we're not going to be getting this data that we're expecting here. So since we're not using actual database data, what we can do is use this mock object that was generated by GoMock to return fake data. And the way we do that is right below book service, we can do book service dot and use this expect function here. And then on that, we'll call get all books. And if you recall, the get all books function takes in a context object right here. But we don't really care what that context object looks like. So we can go ahead and pass in here gomock.any, which will match any object passed into it. So we're saying that when get all books gets called with any argument, then we're going to return, and here we can declare the fake data that we will return. And so in this case, just so we don't have to change our JSON string below, we can just have that fake data be the data that was previously in our database. So remember that a getAllBooks call returns a query.book slice and an error. So the first return value will be a slice of query.book, and the first book in there will have an ID of 1, a title, the pragmatic programmer, the author is David Thomas, and then the next book will be an ID 2, title of Refactoring, and the author is Martin Fowler. Excellent. So again, what we're telling GoMock is when getAllBooks on the service struct gets called with any context object, return a slice of books equal to this. And so now the behavior that is really being tested is whether the controller is appropriately turning this slice into JSON and then responding with that JSON. And because we're using mocks here and this fixed return data, we don't have to worry about the data in our actual database changing. Now, I almost forgot, we need to have a second return value for the nil error that is returned. So now when I go and run go test on the controller, we pass. So just to reiterate here, we're using GoMock to create a mock book service so that we can avoid running the real book service that will hit a real database. Now there are a bunch of other cool methods on this expect object here, one of them being times, which declares the exact number of times that the function should be called. So if I set times to 2, for example, and then rerun the test, it fails because it says we're expecting this to be called twice, but it was only called once. Here we see aborting test due to missing calls. But if I change it now to 1 and rerun the test, we see that the test passes. Now, the cool thing about the layered architecture is that if you actually did want to include the service behavior in this test, you could just mock out the repository and keep the original service layer. So to show you what I mean, let's go ahead and mock out the repository, but use the real service. In my terminal, I'll run the same mockgen command, but instead of running it on the service package now, let's run it on the repository package. So here I've changed the command to use repository.go and to use the repository package with the book repository interface. Now we see if we do ls mocks that it spits out a repository.go, and we can start using the mock book repository instead of the mock book service. So here in the test, I will go ahead and do a book repository now, and we'll do mocks.newBookRepository, pass in the controller. And now instead of the mockbook service, I'll do our actual service, service.newBookService, and we pass in the book repository that is the mock. So now our expect is undefined because we're using the actual book service now, but if we replace this with book repository, then we should be working again. This is because book repository has the same getAllBooks method and essentially returns the same data, so we don't really have to change anything about this mocked out getAllBooks method. I'll go ahead and move this down below, and so now we have a real service, a real controller, but a fake repository. So again, if you wanted your unit of code to be the controller plus the business logic in the service, this is how you would do it while using mock data and avoiding hitting the actual database. So again, in the terminal, I'll run go test, and we see that it passes again. So hopefully you can see now that this GoMock package is really powerful for generating mock implementations of your interfaces and also making assertions on those mocks. One thing, of course, is that you'll probably want to keep updating and generating those mocks as you update your interfaces and you update your code. So what I would highly recommend is using something like a Makefile to store the mockgen commands and your test commands, and so that it all runs seamlessly without you forgetting to generate your mocks before you run your tests. So the way I'm setting this up in my projects is I'll create a Makefile and I'll create a mocks rule for each of my packages. So for the repository package, I'll do repository mocks, And here is where that mockgen command would go for generating repository mocks. And then for our service package, we would have service mocks with the service mockgen command. And then finally, I would have a rule for testing. So do test. And this would depend first on generating those mocks. So you could do something like mocks is repository mocks and service mocks. And then test is mocks and then the actual test command. So this test command will run all of the tests in our repository. So now if I want to make the mocks, I can do make repository mocks. And if I want to make service mocks, I can do make service mocks. And if I want to run a test, I can do make test, and it will run the mockgen commands first before it runs the tests. So now you could add mocks to your gitignore. Here I'll just do rm/rf mocks. And if I run make test, it's going to generate those mocks before it runs the tests, and the test is going to pass without a problem. Great, so I hope this video was helpful. Just to recap, we separated our layers into different Go packages, and we wrote a test for the controller layer. The first test we wrote was an end-to-end test that hit our actual database. And because we might not want to be forming those database connections during our tests, or we want to isolate the actual behavior of the controller layer, we used GoMock to generate mock implementations of our interfaces. And then we plugged those mocks into our tests to create mock data, which we then asserted upon. We also created a Makefile to sort of orchestrate the code generation and testing for us. So now we're left with an elegant and simple to test architecture where we can easily isolate the behavior of each layer. I hope you found all these tips useful. Please let me know if you have any questions in the comments below. And as always, I look forward to seeing you in the next one. Thanks for watching.